In section 2.4, we're working with applications of piecewise functions. The essential question in starting this section asks, how can we write and graph piecewise functions given a real-life situation? All right, so first we're going to be given these graphs, and we're asked to write an equation for the individual parts of the graph. And then we're going to give the domain for each individual part, and then we're going to put it together in a piecewise function. So in the first one, and before we do these, it's going to be very helpful if you remember the basic shapes of the functions. Primarily for these, of course, this is a straight line. And in order to get the equation for a straight line, it's really useful to be able to determine the slope and the y-intercept. And once you have that information, you write it in y equal mx plus b form. If we see any piece of this shape, that would be the x squared function. So if we see a part of a parabola, then we'll want to use that. And those are probably the only ones that we're going to be working with here. So let's look at the first example. We've got two rays. The first one goes all the way up to the y-axis and stops. The second one also starts at the y-axis and then it continues. So I'm going to start. You want to look at where the domain, you want to look for any breaks in your graph. So I see a break in my graph here. And I can see that that's happening. I'm going to ask myself, what x value is that at that point, Here and here, the x coordinate is 0. So I can see that the domain is going to change around x equals 0. On my graph, I'm going to just draw a dotted vertical line through x equals 0. That way I can kind of partition my graph off into sections based on where those pieces fall. So on the left side of the graph, I need to describe this line. I need to give an equation of that line. Well, I can see that it touches the y-axis at 2, so it has a y-intercept 2. And the slope, if you look really closely, you will see that it's passing through at each corner of the grid. So it's passing through at this point, -1, 1, and then it's passing through at -2, 0. So to get from one point to the next, to get from here to here, it goes down 1 and left 1. So the rise over run is -1 over -1. All right, and if you do it again, it goes down 1, left 1 again. So you've got a slope of, so remember your rise over run, -1 over -1, that would give me a slope of +1. So with the slope being 1 and the y-intercept being 2, I have an equation for this piece of my graph. That would be y equals mx, so 1x, plus the y-intercept is 2. So that describes this part. To describe the second piece, the y-intercept this time is at the origin. So my y-intercept is 0, so that'll go in for B. My slope, if I start here, I go up 1 and over 1, and I've got another point on the graph. Up 1, over 1, another point on the graph. So the slope is 1, and the y-intercept is 0. So that would be the equation for the second piece. Or you could think of this, if you need, you could think of this as, oh, my whiteout doesn't work. You can think of this as y equals, the slope is 1, so 1x, plus the y-intercept is 0. And then we'll give the domain for the two pieces. So the first equation happens back here, to the left of this dotted line that we drew through here. So that's everything that's all the x values that are less than 0. And it's not equal because it's got that open circle there. So for our domain in the first equation, we're going to say we're going to say x is less than 0. And then for the second part over here, this is on the right side of the graph when x is greater than 0. So that's the domain for that part. To write our piecewise function, that gives us f of x equals, and we're just going to write x plus 2 if x is less than 0, and we're going to write x if x is greater than 0, because it was 1x plus 0, so we can just write x. Okay, let's look at the second one. Second one, we've got 3 pieces to our graph. So first thing I do is I look at where the graph is changing. I see I've got a flat line until I get to this point, and then it becomes a parabola. So I'm going to put a vertical dotted line through the point where the graph changes. And I can see that's happening at x equal -2. So that line is x equal -2. And then over here, the graph changes again from a parabola to a line at this point when x equals +2. So those are our partitions to help us. So we've got 3 sections, so we're going to have 3 pieces to our function. Starting on the far left, this will be the equation y equals, because it's a flat line, that's a constant function, and it would be points where the y is equal to 4, because it lines up here. So y equal 4 is the first piece. I don't need x, because it's a constant function. In the middle, I've got a parabola, so that would be my x squared function. And I see it touches at the origin, so it's just going to be the regular parent function y equal x squared. And then the third piece over here, we've got a line again. We need a slope and we need a y-intercept to describe that line. Looking at the picture, again, I noticed that the line is passing through the grid at the corners. So I can see that from one point to the next, I'm going up 1 over 1, up 1 over 1, up 1 over 1. So that means my slope here is 1. And I'm going to put a note, m equals 1. And then, what is the y-intercept? Well, if I've got a straight edge, which I don't currently have, but I'll take this sheet of paper. If I can take a straight edge, and I'm just going to I'm going to extend that line, but I'm just going to do it dotted because I know it's not really going this far down. But if I can extend that line, I can see that it actually would touch the y-axis there when y equals 2. So my y-intercept here would be 2. So I'm going to number these. That was my first equation, second equation. Now my third equation for this part is y equals, my slope is 1, so 1x plus y-intercept would be 2. Now let's give the domain for each piece. So going back to the far left, the domain here is going to be everything less than x equal -2. So x is less than -2 in the first one. In the second one, that domain, it runs from this dotted line to this dotted line, so x equal -2 to +2. So I'll say -2 is less than or equal x, and that's less than or equal to 2. And then for part 3, my domain here would be everything greater than that dotted line, or 2. So x is greater than 2. And now I'm ready to write my piecewise function. So I'm going to write top line y equal 4. Oops, I don't need the y, sorry. Top line is just going to be 4. I don't need an x there because it's a constant function. So it's going to be 4 if x is less than -2. So that's the domain. Second one is going to be x squared if x is between -2 and +2. So -2 less than or equal x less than or equal to 2. Third equation is x plus 2 if x is greater than 2. And that's it. It's such a pretty day. I've got the window open, so you're hearing a lot of cars go by on the road because it's close to the road. All right, graph 3. Okay, so let's find where the graph changes and put a dotted vertical line through those points. I can see that one occurs when x equals -1. and then it changes again over here, and this occurs when x equals positive 1. So starting with the far left, this is a slant line, so it needs a slope and a y-intercept to describe it. So let's do the slope first. This one is not so easy to see because I don't have a good grid behind it, but it appears to be going, like, let's say from here at this point to this point, it looks like it's up 1 over 1. So it appears to have a slope of 1. So we're going to say slope equals 1. Y-intercept, if I could extend the line a little further, I can see that it would be touching the y-axis at y equal 2. So we're going to use 2 for b, and then we can write the equation y equals 1x plus 2. For equation 2, in the center, that's a constant function, y equals 1, all the way across, y equals 1. And then for the last one, part 3, it looks like a steep line, but it also kind of looks like it might have a curve to it. So let's play with some points. If I put in 1 for x, I get 1 for y. If I put in 2 for x, then I would come all the way up here, and it looks like I might be hitting it at 4. So to get from 2, if x is 2 and y is 4, I would get that by squaring it. So I'm looking at this as part of a parabola, which means it would be the equation y equals x squared. So those are the 3 pieces that we need, and now we need to give the domain. Going back to the left side, the domain is going to be x is less than or equal to -1. The middle section occurs between -1 and +1. So -1 less than x less than +1. And number 3 occurs when x is greater than 1. And now we're ready to construct our piecewise function. So we're going to say the first piece is going to be x plus 2 if x is less than or equal to -1. Second piece is going to be 1 if x is between -1 and +1. Third piece, y equals x squared, or we're going to say x squared if x is greater than 1. And that's it there. Hope that's all showing up for you there. All right, last one. This time I see breaks in the graph. So every time it breaks, I need to draw a vertical line through that point. And I'm going to label that. That's happening when x is equal to -1. And then I see it happens again over here, and that happens when x equals +1, because it's 1 mark over from the origin. So starting with the far left piece, that's a slant line. It needs a slope and a y-intercept. If I could extend my line a little further, it would be touching the y-axis here when y equals 2. That would be, that's 2 spaces up. So this piece of our graph has a y-intercept of 2 and a slope for this one. Again, it passes through the grid at the corners, so the rise over run is 1 over 1, 1 over 1, so your slope is 1. So your equation would be y equal 1x plus 2. And the second one has an open circle. Doesn't show up too well, but it has open circles at the front, at the left and the far right and the center. And this one, again, because it's a line, we need to have a slope and a y-intercept. So this one, it goes up 1 over 1, up 1 over 1. So slope is 1. Y-intercept, I can see, is 3. So my equation is y equals 1x plus 3. And the third piece, if I could extend this one a little further, it would touch the y-axis at 1. So it has y-intercept 1. Slope is rise over run is 1 over 1, 1 over 1. So slope is 1. So this equation is y equals 1x plus 1. All right, going back to the first equation on the left, the domain here is going to be all x values less than -1. Or actually, it's going to be all x values less than or equal to -1. I need to include equals because the closed-in circle is on this piece of the graph. So my domain, that means my domain here, x is less than or equal to -1. In the middle section, the domain is everything between -1 and +1. And it's got open circles on the ends. So that means that this time we do not use an equal sign. So we're going to say -1 is less than x is less than +1. And then for part 3, the domain is going to be x greater than or equal to +1. And now we're ready to build our function. So the first equation is x plus 2, or the first piece is x plus 2, and that happens if x is less than or equal to -1. The second piece is x plus 3. That happens if x is between -1 and +1. And the third piece is y equal x plus 1. That happens if x is greater than or equal to 1. Okay, so I did this in bright green ink so that it would show up really well in your video for you. You should be using a pencil for graphs. Well, you should be using a pencil anyway, but especially when you're working with graphs, you don't want to use ink. I don't want to use it either, but I want you to be able to see what I write. Okay, so page 2. Okay, so using a piecewise function. This says, zoom in just a little bit here. All right, so you have a summer job that pays time and a half for overtime. That is, if you work more than 40 hours per week, your hourly wage for the extra hours is 1.5 times your normal hourly wage of $7. Write and graph a piecewise function that gives your weekly pay, P, in terms of the number H hours you work. Okay, so we need to label this. We're going to let the x-axis represent the hours that you work, so we're going to label that as hours. And then the y-axis, we were told it should represent weekly pay in terms of the number of hours you work. Okay, so we're gonna put over here pay per hour. It's really important to make sure you're labeling your graph. So that's what we mean when we say label it. Tell us what it stands for. So the x-axis represents hours, the y-axis represents the pay per hour. All right, and then to set this up, we know that for the first 40 hours, your rate is $7. And then if you go over 40 hours, 40 plus hours, your rate is 7 times 1.5. Well, 7 times 1.5 is going to be $10.50. So we can write a piecewise function from that. We're going to say that P of H, and H is going to be hours and P is going to be pay. So where it's got X and Y, I'm going to put H in place of X and P of H in place of Y. So our function is going to be P of H equals 7 if H is between 0 and 40. That should be H. It's going to be 1050 if h is greater than 40. And then we have to graph that. So we've got to determine how to do our scale before we start trying to graph it. Hours worked would be anything from 1 to 40 or more. So to label that, let's do, let's maybe count by 5. So 2 spaces would be 10, 2 more would be 20, 40, 50. So that would give us up to 60, which is reasonable. And then our pay per hour, let's do that one. You can make your pay per hour is going to, the highest you're going to be making per hour is $10.50. So you're not going to need to go any higher here. So you could count by ones this time. Okay. So P of h is going to be 7 for all values of h between 0 and 40. So if you put, if you wanted to do a table for this, if you put in 5 for h, so 5 hours, you make $40 an hour. So you can come up here and you can mark, I'm sorry, you make $7 an hour at 5 hours. If you work 5 hours, you're getting paid $7 an hour. If you work 10 hours, you're getting paid $7 an hour. If you work 30 hours, you're getting paid $10 an hour. So anywhere between 0 and 40 hours is going to be on this same, it's going to be a constant function at $7, all the way up to 40. So this would be the first piece of your graph here. It's got a closed circle. If you go above 40, then you're going to be making $10.50 an hour. So you can go to 40, and then you can jump up here to $10.50, which is going to be about right there. I'm going to put an open circle here, because if I actually work 40 hours, I don't get overtime. I have to go beyond 40 hours. But if I work 41 hours, I make $10.50. If I work 45 hours, I make $10.50. If I work 55 hours, I make $10.50. So it's going to continue as a constant function indefinitely that way. So that's what your graph would look like. Oops, sorry, there. That's what your graph would look like. All right, they ask what is the domain? Well, just looking at the graph, the domain goes from 0 hours all the way out to positive infinity. Then it asks what is a reasonable domain. You cannot work an infinite number of hours. So a reasonable domain might be up to maybe 84, because it's unlikely that you would conceivably work more than 84 hours a week. So we'll just say the reasonable domain would be from 0 to 84. And then it wants to know how much will you get paid if you work 45 hours. Okay, so if you get paid 45 hours, you're going to make $7 for the first 40 hours plus $10.50 for the remaining 5 hours. So doing those calculations, that's going to be $280 plus $52.50. And that would give you $332.50. Okay, let's look at the second one. Your favorite dog groomer charges according to your dog's weight. If your dog is 15 pounds and under, the groomer charges $35. If your dog is between 15 and 40 pounds, she charges $40. If your dog is over 40 pounds, she charges $40 plus an additional $2 for each pound. Okay, so same directions. We have to write and graph a piecewise function, and we need to start by labeling our graph. So the amount that you're paying is going to depend on your dog's weight. So we need to put weight on the x-axis, and this is measured in pounds. And then the charge would go on the y-axis. All right. So let's set up a function here. This is the x-axis is, we're going to do W for weight. Y is going to be charge based on weight. So charge is a function of weight. So for our function, we're going to have C of W equals, and it's going to have, how many pieces is this going to have? If your dog is 15 pounds and under, it's going to be $35. So we're going to say 35 if the dog's weight is between 0 and 15. Notice it said if your dog is 15 pounds and under, so you would include equals at the 15. If your dog is between 15 and 40 pounds, she charges $40. Okay, so we have 40 if weight is between 15 and 40. So since we had equals there, we're going to have a less than here, all the way up to 40 pounds. If your dog is over 40 pounds, she charges $40 plus an additional $2 for each pound. Okay, so what we can do is we can multiply 2 times the weight of the dog. If we're in, so let's say you got a 50-pound dog. You're going to have to pay $2 times 50 pounds, but then you can subtract $40 because it was already included in there. So you would have double the weight minus the $40, and that's going to happen if the weight is over 40. Okay, and to get this all on our graph, so if we're looking at the weight of the dog, maybe it goes all the way up to a 100-pound dog, so maybe counting by 5s here would be a good idea. This is going to get me up to 60 for my graph. And then for the cost, we could do, let's see, so $40 give or take depending on the size. So let's count by 5s here. So they ask in part, so we need to, up to 15 pounds, it's going to be $35. So all the way up to here, we're going to find 35. So there. So all of these are going to be, oops, I'm sorry, I put that in the wrong place. 35 is here. And it's going to be 35 up to 15 pounds. And that includes 15, so we can put a closed circle at the 15. 40 pounds if the weight is between 15 and 40. So we need to, so once we get past 15 pounds, we're going to jump up to 40 and put an open circle because it does not have equals. So all the way up to 40, we have to pay $40. And then if the weight is more than 40, it's going to be 2W minus 40. So that would be, so if we start where we're leaving off, we have a slope of 2. So we need to go up, we need to rise 2 and run 1. Rise 2 and run 1. And that would be our graph for that piece. So those would be my 3 pieces. Now, why did I start right here? How did I know I could just start from there? Well, because at 40 pounds, we knew it, they charged $40. If it's 40 pounds and 1 ounce, then they go to this piece. So when it's equal 40, it's going to be this one, and when it's greater than 40, it's just going to be picking up right where there's no break in the graph, because you're not going to be changing from, if you go from 40 to the next increment, there's not going to be a significant change in the domain there. So we can just keep it like it is. Just stay right there and then go up. So this is what my graph looks like. Part A, what is the domain? All right, so the domain of the graph, it goes from 0, okay, and it goes all the way up to 15, and then it picks up on the other 15. So even though there's a break in the graph, there's not a break in the domain there. The domain is defined straight through. And then it continues all the way to positive infinity. So the domain is going to be 0 to infinity. What is the reasonable domain? Okay, so you're not going to have an infinite sized dog. So you might have up to maybe I don't know how dogs run. I'm going to guess maybe 200 pounds. 0 to 200 pounds. What would you be charged if your dog weighed 60 pounds? If your dog weighs 60 pounds, that's going to put you down here in this category. So you're going to put 60 in for W. So 2 times 60 minus 40. That's 120 minus 40. And that's going to be $80. Okay, so that completes the notes for section 2.4. You should now be able to do the homework exercises from this section. And let me know if you have questions.